Hello math friends, this is Precalculus section 6.5 notes, the last section in chapter 6. Today we are going to be talking about the law of cosines. This again should be review material from geometry. So in any triangle ABC we're going to call this, where again capital A, B, and C are the angles and lowercase a, b, and c are the side lengths. The law of cosines looks like this, and it can be in terms of side A, side B, or side C. A squared is equal to B squared plus C squared minus 2 times B times C times cosine A. Or we could write it in terms of side B. B squared is equal to A squared plus C squared minus 2AC cosine B. Or finally, we could write it in terms of C squared. C squared equals A squared plus B squared minus 2AB cosine C. So for example number 1, they want us to find the angle measures in triangle ABC. And we are given our 3 side lengths. So if we want to find the angle measures, it's a lot easier if we first take a look at our equation and just kind of transform it so that we're looking at what cosine A would be equal to, what cosine of B would be equal to, or what cosine of C would be equal to. Okay? So if we want to start by finding the measure of angle A, the first thing that we're going to do is we're going to rewrite the equation so that it is cosine A equals. So if you look at the equation, the first one that we wrote above, if we want to isolate that cosine A, the first thing we're going to do is we're going to subtract the B squared and the C squared over to the other side of the equal sign. So we would have cosine A is equal to A squared minus B squared minus C squared. That would all be in the numerator. And then the negative 2BC times cosine A, if we want to get that cosine A alone, all of those things, the negative 2, the B, and the C, are all being multiplied. So we're then going to divide by negative 2BC. So all of this divided by negative 2BC. And this right here is a very handy equation because now we can use it to solve for angle A. So I'm going to go ahead and I'm going to plug in A, B, and C into this equation. So cosine A is going to be equal to 5 squared minus 12 squared minus 8 squared divided by negative 2 times 12 times 8. And then you grab your calculator, and I think it's easiest to simplify the numerator first and then the denominator. So if we grab our calculator and we simplify the numerator, you should get negative 183. You simplify the denominator, you should get negative 192. And then when you divide those things, you end up with 0.9531. So now that is what cosine A is equal to. So if we want to know the measure of angle A, that's going to be equal to the inverse cosine of 0.9531, which again, you grab your calculator and you find out that angle A is 17.6 degrees. Our next step is going to be to find the measure of angle B. So we're going to start by doing the same thing. We're going to transform the law of cosines equation so that it's cosine B is equal to, it's going to be the exact same math that we did before. So cosine B is going to be equal to B squared minus A squared minus C squared divided by negative 2 times A times C. Again, kind of a handy formula to know. So now we're going to go ahead and we're going to solve for angle B by plugging B, A, and C into this equation. cosine B is equal to 12 squared minus 5 squared minus 8 squared divided by negative 2 times 5 times 8. Again, you grab your calculator. Let's do the numerator first. 12 squared minus 5 squared minus 8 squared is going to give us 55 in the numerator. In the denominator, negative 2 times 5 times 8 is going to be negative 80. And 55 divided by negative 80 gives us negative 0.6875. So now we know in order to find the actual angle B, we're going to need to use the inverse cosine. So angle B is going to be equal to the inverse cosine of negative 0.6875. Grab your calculator, make sure you're in degree mode, and we find that angle B is 133.4 degrees. The last angle that we need to find in our triangle is the measure of angle C. We are going to start by transforming that C squared equals equation. So it's going to look like the cosine of C is equal to C squared minus A squared minus B squared divided by negative 2 times A times B. Now that we have this equation, we're just going to take A, B, and C and plug them in. The cosine of C is going to be equal to 8 squared minus 5 squared minus 12 squared divided by negative 2 times 5 times 12. There we go. And this is how we would set it up, but there is another option here. Since we know 2 of our 3 angles already, the other option would be that we can just subtract from 180, which is actually easier. So I'm going to pause here. If you wanted to continue this math, you could, but the other way is to say that angle C is going to be equal to 180 degrees minus 17.6 degrees minus 133.4 degrees, which leaves us with the measure of angle C being 29 degrees. So there we go. We have used the law of cosines to solve for all 3 angles in this triangle. In the next example, we're asked to solve another triangle. This time we know the measure of angle A is 46 degrees, side B is 10.5, and side C is 18. Okay, so we're going to begin by finding side A first. That would be helpful because we know sides B and C and we know angle A, so we can use the law of cosines for that. So we are going to start with A squared equals B squared plus C squared minus 2BC times the cosine of angle A. And we're going to go ahead and plug in that information. So A squared is going to be equal to 10.5 squared plus 18 squared minus 2 times 10.5 times 18 times the cosine of 46 degrees. You grab your calculator, be very careful how you type this in. This is something that you do need to practice to make sure that you have your order of operations typed in correctly. You should get that A squared is 171.7, and then of course you square root that, and you get that A is approximately 13.1. Okay, so now that we know that, at this point, you could switch to the law of sines, but be careful because the law of sines has the ambiguous case. Okay. All right, so now that we know a combination, a side angle combination, now we know angle A and side A, now we can go ahead and say, well, sine of A over A is equal to sine of B over B. We can use that to find angle B. So I'm going to start there. I'm going to say sine A over A is equal to sine B over B. And now I'm going to plug my numbers in here. So I'm going to get the sine of 46 degrees divided by 13.1 is equal to sine of angle B, which I'm trying to find, divided by 10.5. Okay, we do our fancy mathematics here. We get the sine of angle B is equal to 10.5 times the sine of 46 degrees divided by 13.1. So the sine of angle B is 0.5766. And of course we have to find the measure of angle B, we have to do the inverse sine of 0.5766. And we find that angle B is 35.2 degrees. Okay, now we know angle B, we can find angle C just by subtracting from 180. So the measure of angle C is going to be equal to 180 degrees minus the 46 degrees, which was angle A, minus the 35.2 degrees, which is angle B. So we find out that angle C is 98.8 degrees. Okay. So now we've solved this triangle. However, because we use the law of cosines, we have to check and see, is there a second triangle? So remember, when we do that, we always go back to the first angle that we found, which in this case was angle B, right? And we found that angle B was 35.2 degrees. Or the other option is it could be 180 minus 35.2, which would make it 144.8. So if angle A was 46 degrees plus this alternate angle B, we'll call it angle B prime, is 144.8 degrees, then that already totals 190.8 degrees. Okay, so there's no room left for an alternate angle C here, which tells us that no, there is not going to be a second triangle in this situation. So now we just have a little summary here of when to use the law of cosines and when to use the law of sines. We want to use the law of cosines when the given information either satisfies a side angle side situation or a side 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 situation. And we're going to use the law of sines when the given information satisfies either angle side angle, side angle angle, or the side side angle, which of course is our ambiguous case that we have to be wary of.